Now, what is calibrating a thermometer? Calibrating a thermometer means to put a correct mark of the reading at the correct place. For examples, if you have a thermometer, okay, so and then you have a liquid. Now, how do we know where is 20 degrees Celsius? Where is 20 degrees Celsius? Okay, if you put a mark here, say this is 20 degrees Celsius. Oh, okay, then this means you have calibrate. You have calibrate this thermometer. Okay, you put another mark that says, oh, 80 degrees Celsius is here. So you put a mark, correct mark at the correct place. Then this is called calibrating a thermometer. And this is true for all kinds of measuring instrument. Okay, so as long as you put the correct mark at the correct place of the measuring instrument, then we say you are calibrating that measuring instrument. For thermometers, usually we use the steam point, which is 100 degrees Celsius, and the ice point, which is 0 degrees Celsius. Ice point means it's a freezing point, and the steam point means that is the boiling points of pure water, and the freezing points of pure water. So we use this point to calibrate a thermometer. How we calibrate? Okay, this one. Okay, first we put the thermometer. You see, this thermometer has no scale. Okay, so we put this thermometer into an ice. Okay, for a few minutes, and we see where is the mercury. Okay, the mercury is here. Okay, if the mercury is here, then we put a mark here, and then we say this is 0 degrees Celsius, because we know that the ice will melt at 0 degrees Celsius. So this is 0 degrees Celsius. And after that, we put this thermometer inside a boiling water, on top of a boiling water. On top of a boiling water, there's a steam here, right? So the temperatures of the steam is 100 degrees Celsius. And just now we already have 0 degrees Celsius here. Let's say that you go up to this point, okay? Then this is 100 degrees Celsius. So now you have two. So you have 2 points already, yeah? Okay, let's say you have a 0 degrees Celsius here, and then you have your 100 degrees Celsius here, okay? And then let's say the distance from these 2 points are 10 cm, okay? So if the mercury, the length of the mercury go to this point, okay? So from here to here, 10 cm. So now it go to this point. This point is 3 cm. So 3 cm. So if it's 3 cm, then what's the temperature here? What's the temperature here? From 0 to 100 degrees Celsius is 10 cm. But this one, the length of the mercury is only go to 3 cm. So 3 cm, 30 degrees Celsius. 30, yeah? But if you go to, let's say 6 cm, 6 cm is from here, 6 cm from here, okay? Then it will be 60 degrees Celsius. So 3 cm is measured from here, okay? 3 cm from here, or 6 cm from here, 60 degrees Celsius. So you see, once you get 2 points, 2 mark in a thermometer. Then from these 2 mark, then you can mark the other mark. Okay, if it's 10 cm, then you mark 10 mark here. Then you have 10, 20, 30, 40, 50. Okay, if you make 100 mark, then you will have 1 degree, 2 degree, 3 degree to 100 degrees Celsius. So we get the ice point, boiling point, and then we make 100 mark between these 2 points. That each point represents 1 degree Celsius. Then we can measure any temperature. So after finding the positions of the ice point and steam point, and then the temperature can be determined by using this formula. Okay, theta, this is temperature. L theta is the length of the mercury when measure this temperature. This is the length of the mercury when it's 0 degrees Celsius. This is the length of the mercury when it's 100 degrees Celsius. And this is the length of the mercury when 0 degrees Celsius. And then we times 100 degrees Celsius. Now, how to use this? Let me give you one example. Let's say we have a thermometer. You measure the ice point. You'll find that it's 3 cm. 3 cm. Which means your L0 is 3 cm. And then you put this on top of boiling water. It go to these levels, okay? It go up to these levels, okay? And then this one, okay? The length from the bulb, the length is, let's say 18 cm. 15 cm. 15 cm. And this is your L100s. L100s equals to 15 cm. Now, you already have your 2 point. okay, the ice point and the steam point. So now you use this to measure, let's say you want to measure your room temperature. So you put these thermometers inside your rooms, and then you find that, okay, this 3 cm, this 3 cm, you'll find that it is 6 cm. So the liquids, it go to 6 cm. So it go to 6 cm. So this 6 cm, we call this the L theta. That is the temperature length, or when you measure the temperature, okay, 6 cm. Now you have your L0, L100, and L theta. Then you can calculate the temperature. Okay, you can calculate temperature. So the temperature is equal to 6. Okay, 6 minus L0, which is 3, divided by L100, which is 15, minus L0, which is 3, and then times 100 degrees Celsius. And this is equal to 3 over 12 times 100 degrees Celsius, and this is equal to 25 degrees Celsius. Then now you know your room temperature is 25 degrees Celsius. So that's how we use a calibrated, just calibrate the ice point and the steam point only. Yeah. So how to use this calibrated thermometer to measure the temperature of an object. The length of the mercury column in a non-calibrated mercury thermometer is 2 cm when its bulb is immersed in melting ice, okay, which means your L0 is equal to 2 cm. And it's 20 cm when the bulb is in steam, okay, so your L100 is equal to 20 cm. What would the temperatures be? Is the length of the mercury column is 11, so that's your L theta. Your L theta equals to 11 cm. Okay, so what's the temperature? Okay, let me give you the formula. Theta equals to L theta minus L0 divided by L100 minus L0 times 100 degrees Celsius. Okay, tell me, what's your temperature? L theta 11, L0 2, L100 20, L0 2 times 100 degrees Celsius, and this is equal to 9 over 18 times 100 degrees Celsius, okay, and this is equal to 50 degrees Celsius. Yes. So that is how we use calibrated thermometers to find the temperatures of an object.